In this video, we learn about trusses. In the previous chapter, we learned about different types of beams and support reactions. Beams are one of the most important structural support. Similarly, trusses are another type of support structure which is used extensively around the world. You might have seen this structure used in long bridges over a river, or a train track between two junctions, or in a stage structure at the event. The trusses are widely used due to its load-bearing capability and easy construction. For example, if you consider a roof, we can have beams running across the width of the roof and support these beams with a few pillars placed across the floor. The pillars will obstruct the long floor. If we use trusses, we should support it only at the extreme points or joints. The structure of the truss is such that the load will be acting at these joints and not in the members connecting these joints. So, you get a long unobstructed floor beneath the roof. This is the reason for trusses to be used in construction of a bridge. As you cannot have proper pillars in the water, truss allows you to support it at the extreme joints. This is the major advantage that the trusses have over many other support structures. Now, let us look at the structure of a simple truss. Here we have a simple plain truss. A truss has three basic parts. The first one is the top chord, the beam at the top, which is usually in compression. And then we have the bottom chord, beam at the bottom, which is usually in tension. Finally, the webs, the interior beams. These members are connected in different ways. Based on that, we have different types of trusses. We have two major types of truss: planar truss and space truss. In planar truss, all the members lie in a two-dimensional plane, while space truss lies in three dimensions. There are a variety of trusses available depending on the requirement, including span length and loading condition. Basically, two types of trusses exist: bridge truss and roof truss. The trusses are also classified based on the number of members. So, we have rigid truss or perfect truss, non-rigid truss or deficient truss, and over-rigid truss or redundant truss. In rigid truss, the number of members is sufficient to resist the external load. The deformation is minimum 2. In non-rigid truss, the number of members are less than required to make it a perfect truss. In over-rigid truss, the number of members are more than required to make it a perfect truss. The relationship between the members and joints will decide whether the truss is perfect or not. That relationship is M is equal to 2j minus 3 for perfect truss, M less than 2j minus 3 for non-rigid truss, and M greater than 2j minus 3 for over-rigid truss. The members of any type of truss will be subjected to either compression or tension based on the load applied. This is all about trusses and its types. In the next video, we learn about the analysis of trusses. See you there.